Hi, welcome back to the channel. In today's lesson, we'll see how to calculate electric force between 3-point charges. I'll use a work example to help us understand it better. That said, let's get into class. Now, here is our question. Our question wants us to calculate the resultant force on these 3 microcoulomb, which is due to the 4 microcoulomb. The 4 microcoulomb is a negative charge and the 10 nanocoulomb charge, which is a positive charge. I want us to start with calculating the force acting on this charge first. Let's tag the force. The force due to the 4 microcoulomb, I would like to tag it F1, and the force due to the 10 nanocoulomb, I like to tag it F2. Now, because the F2, because my 3 microcoulomb and the 10 nanocoulomb are both positive charges, obviously there will be a force of repulsion between them. That is, I'll have this going in this direction, while I'll have my 10 also going in this direction. But for the 4 microcoulomb, because the 4 microcoulomb is a negative charge, while the 3 microcoulomb is a positive charge, here we'll have a force of attraction between them. So I should have it this way, and I'll have it this way. So that we'll be talking of two forces on the 3 microcoulomb. That will be F1, here will be F1, and also here will be F2. Now, the first thing I want us to do is to calculate our F1 and F2. From our last lesson, we know that the force on two charges is the same thing as Q1, Q2 over R square with a constant of K. So that this here for F2, or let's start with F1. For F1, my K, where my K, I know my K is the same thing as 9 times 10 raised to power 9. I'll say this is F1, I'll be 9 times 10 raised to power 9 times Q1. Q1 is 3 times 10 raised to power minus 6 times 4 times 10 raised to power minus 6 all over R squared. Now, the distance between them, we've been told the distance between each of the charge is 50 centimeter. Now, this is 50 centimeter, and here also is 50 centimeter. I have it to be 50 centimeter, so that this will be 50 centimeter is the same thing as 5 or 50 times 10 raised to power minus 2 meters. Now, this will be the same thing as 15 times 10 raised to power minus 2 all squared. So that F1 will be the same thing as 9 times 3 times 4 over 50. I want to just remove this 50. That will be 250. 50 squared, that's 250. Now times 10 raised to power 9 minus 6, then plus 4, because of this 10 raised to power minus 2. Minus 2 times 2, that's minus 4, but it's 1 over 10 raised to power minus 4, it becomes plus 4 up here. So putting all this together from my calculator, F1 will be the same thing as 4.32 times 10 raised to power minus 1 Newton. Now let's calculate for F2. So that similarly for F2, we'll be talking of my Q1 here also is 3 times 10 raised to power minus 6 times Q2, which is 10 times 10 raised to power minus 9 times 9 times 10 raised to power 9 all over R squared 50 times 10 raised to power minus 2 all squared. So that F2 now will be the same thing as 1.08 times 10 raised to power minus 3 Newton. Now we now have our F1 and F2. F1, we've gotten F1 to be 4.32 times 10 raised to power minus 1, and we've gotten F2 to be 1.08 times 10 raised to power minus 3. Let's draw our figure so that F1 is the force between the 3 microcoulomb and the minus 4 microcoulomb, and we already agreed is in this direction. So F1 here is the same thing as 4.32 times 10 raised to the power minus 1, and F2 in this direction is the same thing as 1.08 times 10 raised to the power minus 3. Here is in Newton, and here also is in Newton. Now, the next thing is to find the resultant forces. Now, remember from the question told us that this is an equilateral triangle. We've been told it's an equilateral triangle, so that the angle between each of the charge is 60 degrees. Now, what I have here will be 60 degrees. What I have here will be 60 degrees, and what I should have here also will be 60 degrees. Now, this is a straight line. This is a straight line which has 120 degrees. So if from here to here is 60 degrees, from here to here also will be 120 degrees. Now, let's form an equilateral triangle. So we use an equilateral triangle to actually solve this. So that I'll have this in this direction, so that the resultant force now moves this way. So I can tag this as F, which is my resultant force. Now, if I have 120 in this angle, definitely opposite here, I'll have 120 for my equilateral, and at this point here, I'll have 60, and at this point, I should have 60. So now I have my triangle. This is 1.08 times 10 to the power minus 3. Here also will be 4.32 times 10 raised to the power minus 1. So that here now we can apply our cosine rule. Cosine rule tells us that c squared, that is the angle, this side is the same thing as a squared plus b squared minus 2ab plus c. In case you are not familiar with how to calculate resultant forces, I'll place a link to our lesson on how to calculate resultant force, and also where we explain cosine rule, so that you can have access to those lessons. And my c squared will be the same thing as 4.32 times 10 raised to the power minus 1 all squared plus 1.08 times 10 raised to the power minus 3 all squared minus, that's minus 2 into 4.32 times 10 raised to the power minus 1 into 1.08 times 10 raised to the power minus 3 cos c. Our c here is 60 degrees, cos 60 degrees. So that 6 squared will now be the same thing as 0.1866 plus 1.1664 from my calculator times 10 raised to the power minus 3 minus 0.000465. Altogether, my C at the end of the day, which is the resultant force, will be the same thing as 0.433 Newton. With this, I hope you understand how to calculate electric force between 3-point charges. We'll get one or more questions to solve in our subsequent classes to help you understand it better. Thank you for staying with us, and see you in our next class.